Hi everyone, I am going to introduce our project, which is called Yevis, a system to support building a workflow registry with automated quality control. First, I would like to thank all our collaborators and the communities for their help to move this project forward. I am going to introduce the background of this project and then explain the system design. After my talk, Hiro will give a demonstration of the system. Let's start with the situation around workflow sharing. In the context of open data and open science, we believe sharing resources helps science. However, as many of us are aware, just uploading the research materials do not. From our experience, there are many issues with reusing the computational workflows. For example, the issue of missing license, workflow language syntax errors, missing dependent materials, examples, or tests. To address the issues, communities work on building a principle of workflow sharing. The FAIR workflow is one of them, and they give interesting suggestions for several aspects. It is good to have such guidelines. However, our question is, who should take care of published workflows? In the case of the workflow hub, they ask submitters to fill the metadata as the workflow becomes fair, so the quality of the workflow is up to the submitters. In the case of an F core, a workflow registry for Nextflow, they ask submitters to join the community, and the community takes the responsibilities for workflows. Interestingly, they say that they do not accept the tailor-made pipelines. This is understandable because maintaining workflow needs specific knowledge of the contents of the workflow. So, as we saw from these two examples, there is a trade-off between the reliability and diversity of workloads in a registry. If we ask submitters to maintain the workloads, it brings higher diversity of content, but no guarantee for their reliability. If the registry takes care of the contents will be better reliable, but comes with a scalability issue. Regarding the situation, we want to emphasize that minor workloads matter. There are many workloads for specific purposes. In other words, those expecting a smaller number of users. Those resources are critical to them, but often have a smaller number of contributors. So how can we make and keep these resources truly reusable? Our solution is to lower the cost of workload maintenance by our system. We believe workloads are best maintained by their developers, but they often lack the resources to do. Therefore, we build a system for them to support building their own registry to share workloads reliably. This system, called Yevis, has unique characteristics. We define the Yevis metadata specification, which assists developers to satisfy the requirement of fair workloads. The system performs automatic validation and testing of workloads through our CLI client and GitHub Actions. The system is fully based on GitHub and Zenodo, which requires users no dedicated computing resources. For the system development, we defined a set of requirements that are automatically validated and tested. It has three perspectives: availability, validity, and traceability of workloads with more specific and testable requirements. Here is the overview of the system that let developers satisfy the requirement. The process of publishing workloads with Yevis has three steps. submission, review, and publication. These yellow boxes are actions automatically done by our CLI client. Metadata template generation, metadata validation, running tests, and uploading contents to Xanadu for persistence are performed by the client. This system is specifically powerful and critical for an individual or a community that wants to share workloads but without the expertise and computational resources. The system also generates a tool registry service protocol, which is abbreviated to TRS, defined by the GA4GH cloud workstream, which helps this distributed registries model. We also developed a workflow browser for the registry built with Yevis, which helps users to find and use workloads efficiently. Now, Hiro presents a demonstration of the system. Please enjoy.
From here, we will demonstrate the Yevis system. The approximate demonstration procedure follows the Yevis Getting Started document. Please refer to that document as well. First, we will prepare a GitHub repository as the initial setup. This repository accepts workflows as pull requests, validates and tests workflows with GitHub Actions, and distributes workflow metadata and GA4GH TRS API. We provided a template for the repository. So, please use this template to create a new repository. After that, we need to do a simple configuration of GitHub pages and Xanadu token. Once the repository is created and configured, the TRS API will be distributed via GitHub pages. Next, we will deploy Yevis Web, a web application for browsing workflows. Again, we start with a fork of the repository. After forking, we use GitHub Actions to build and deploy Yevis Web. Select the Deploy Web action. Then, enter information such as the TRS endpoints for the workflow registry we just created. This Deploy Web action automatically builds Yevis Web and deploys it on GitHub pages. This is the deployed Yevis Web, but it does not contain any workflows at this time. Up to this point, this is the initial setup to be done by the registry maintainer. From here, we will follow the actual workflow registration procedure using the command line tool Yevis CLI. We have divided the workflow registration procedure into 3 processes: submission, review, and publication. The yellow boxes in this figure are done by Yevis CLI. Also, the green boxes are done on GitHub Actions. As a first step, we will do the submission process in our local computer environment. As an example of a submitted workflow, we will use a simple CWL workflow. Execute the Yevis CLI make template command with the workflow URL as input. This will generate a file called the Yevis metadata file, which is a collection of workflow metadata. Examples of metadata included in the Yevis metadata file are version, open source license, author information, workflow and its dependency files, test cases, etc. The Yevis CLI automatically collects this information and generates a template using the GitHub API. Here is an example of a Yevis metadata file edited from a template. In this demo, we use the packed CWL as an example workflow, so there are no dependent files. We have also added a test case. This test case is described in a format that is actually executed by GA4GH Workflow Execution Service. After editing the Yevis metadata file, use the Yevis CLI validate command to check the file for correct schema. Next, we will test the workflow by actually running the workflow using GA4GH WES. If no GA4GH WES endpoint is specified, Yevis CLI will automatically launch Sapporo WES on the Docker engine and run the test. Initially, the WES container is not running. When the Yevis CLI test command is executed, Yevis CLI launches the Sapporo WES container. Then, the Sapporo WES container launches the CWL tool container. And, the CWL tool container launches the FastQC and Trimmomatic containers. These containers are the actual workflow steps and execute the actual processes. If the WES execution is completed, Yevis CLI considers the test is done successfully. Finally, we will submit the workflow as a GitHub pull request using the Yevis CLI pull request command. Here, the Yevis CLI performs validation and testing before submitting the pull request. This restriction reduces the burden on the registry maintainer because the portability and reusability of the workflow can be ensured during the submission process rather than the review process. So far, this is the submission process performed by the workflow submitter. From here, we will look the review and publication processes performed by the registry maintainer. The review process takes place on the pull request UI of the workflow registry we just created. The submitted workflow is registered as a pull request. In this pull request, the workflow is automatically validated and tested again on GitHub Actions. In this GitHub Actions script, the Yevis CLI test command is executed as well. The registry maintainer checks these results and then merges the pull request. Once the pull request is merged, GitHub Actions will automatically run as part of the publication process. In this GitHub Actions script, the Yevis CLI publication command is executed. Within this command, all workflow-related files are uploaded to Zenodo, a DOI is obtained from Zenodo, a TRS response is generated using the file URL persisted by Zenodo, and the workflow metadata and TRS response are deployed to GitHub pages. That's all for the workflow submission procedure. Now, let's check the actually submitted workflow. First, here is the result of the request to the TRS API. Next, we browse the results using Yevis Web. The description of the workflow is rendered. We can check the workflow file and its dependency files. In addition, we can check the test results and test cases. Let's also check the files uploaded to Zenodo. Uploaded files to Zenodo are the Yevis metadata file, which is a collection of workflow metadata, workflow description file, workflow file and its dependency files, and test cases. From the above, the Yevis system automates various procedures to build and deploy the workflow registry, to submit workflows, and to publish them. This concludes the demonstration of the Yevis system.